Physical topologies describe how your network looks once it's all put together and it's laid out. In this section, we'll cover each of the physical topologies and discuss some of the benefits and drawbacks that each of them hold. Our first physical topology is the physical bus. Now, a funny way to remember this, if you imagine the terminators as being wheels and each of the computers being people on the bus, it makes it easier for you to recognize this when you see it. Now, when you actually walk up to a physical bus network, you'll notice that each of the computers have their own connection to the same network cable as each of the other computers. Now, you also notice these T's over here, and they stand for termination. Termination is definitely a big deal on your physical bus topology, because if you can imagine your physical bus being like a pipe with a marble in it, if that marble is our data and we were to tilt the pipe either direction, the marble would roll out and we would lose our data. With the terminators in place, or the caps at the end of our pipe, that data will stay in its place and not move outside the network. One of the major advantages of the physical bus topology is that back in its day, because this is very old technology, it was the only thing available to us. So we were pretty much stuck with it. As technology has increased, we have moved beyond the physical bus topology and the copper media that it relies on. One of the major drawbacks of the physical bus topology is that if any one of the computers or any piece of cable failed, it would cause the entire network to go down, because that would then be an open part of the media that is not terminated. Another major disadvantage to the physical bus topology is how difficult it was to create a bus network. You actually had to take these primitive things called a vampire tap and put a spike into the copper media and hope that you hit the copper core to establish the connectivity. So it was a very primitive method, and we don't really use this so much anymore. Let's take a look at the physical star topology. Now, this is a very common topology used today, and the reason it's so common is because it's very simple to set up. You simply get yourself a central connecting device, such as a hub, router, or switch, and connect all of your computers to that device. Your computers will then be able to talk. Now, of course, it's not always quite that simple, but one of the major benefits of this physical topology is that if one computer failed, the rest of the computers would be unaffected, other than if they were trying to connect to the failed computer. One of the major disadvantages of the physical star topology is that central connecting device. If it were to fail, we would lose our entire network. In network terms, this is called a central point of failure and is generally a bad idea. But since our technology has gotten so good, the reliability of these central connecting devices has become very high. So we don't worry about them failing quite as much as we would in the past. Next is the physical ring topology. Now, this is another older technology, and it's kind of making a comeback today in a different form. The physical ring topology basically has a connector on each computer that loops to the next computer. And your data has to complete this circle or you'll lose connectivity. Now, one of the big drawbacks of the physical ring topology used to be a very low data transfer rate. Now, we've overcome that problem now, but we're still faced with the fundamental problem of losing any connection or any computer in that physical ring topology. If any one of these lines or any one of these computers were to fail, the entire network would go down. But again, as our technology has increased, this topology has become very effective in other forms. The physical mesh topology is probably one of the most reliable topologies that we as network administrators have access to. The major benefit to a physical mesh topology is its ability to handle failure, or fault tolerance. If one computer failed, the other computers would have a mode of connecting to each other. If any line failed, the computers would still be able to go through each other to talk to the other computers. There's one fundamental problem with this. Right now, we only have 4 computers, which means we would have to have 3 network cards and 3 cables coming out of the back of each of these computers. Now, that doesn't seem too bad, but if you multiply that times 2,000, and let's say, for example, if we had 6,000 computers, we would have to have 5,999 network cards and that many cables as well. So obviously, for management and cost reasons, we don't use the physical mesh topology in our network environment today. Our final physical topology is the hybrid topology, and is probably going to be what you'll run into the most. In this example, we see a physical bus connected through a central connecting device to other computers that are considered to be in a physical star topology. So we can combine any of our physical topologies to create a hybrid topology. So this should give you a pretty good idea of how physical topologies look once your network's put together. Next, we'll cover logical topologies.